We're going to do a quick review over cables, and the takeaway from cables is we can apply the same method when we're looking at trusses in a few videos, and we're looking at method of joints, okay? So let's just draw something quick here. So I have a cable system, and let's put 1,000 pounds on here, and then let's go up. Let's just put another, I don't know, 1,000 pounds on here. Keep it simple. Let's go up. And let's go up. Okay, so let's put the slope on this, 1, 2. And remember to find the hypotenuse. We use Pythagorean theorem. 2 squared plus 1 squared is 5. So this will be the square root of 5. Let's use a 1, 1 here. So that's an easy root 2. And then let's use a 3, 4. So we should all know that's a 5. Okay. And let's label A, B, C, D, and E. So this might be something that you're given. And the question might be, what are the forces in each of these cables? So one thing to remember with a cable and truss members is they are 2 force members. Okay, so we will have internal, when we get to internal forces, we'll have an internal normal, which is going to be tension or compression. In cables, hopefully just tension, okay? Trusses, tension, and compression. We will not have internal shear. We will not have internal moment. If I cut this cable and I want to look at the internal forces that are taking place, normal would be the only thing that I would see. Okay, so let's start here at B. We need to draw a free body diagram at B. And we show everything in tension. So I have 1,000 pounds. And I'm going to call this tension BC, 1, 2, root 5. And I'm going to call this one tension BA. Okay. Now, why did I start with B? When I have a 2 force member and I'm looking at basically method of joints, okay, the only equilibrium equations I can use are summing forces X and summing forces Y. Okay, because all of these forces are going through the same point, we can't use summing moments. If I look here at B, I have 1, 2 unknowns. If I look up here at C, I have 1, 2, 3 unknowns. So that's not a good starting point because I have too many unknowns for equations. That's B. I can use summing forces X or summing forces Y. If I sum forces X, I have an unknown here and an unknown here. That's 2 unknowns with 1 equation. If I start with Y, I just have 1 unknown. So I'm going to start with summing forces in the Y direction. And again, I'm going to show you my equilibrium rule that I'm using. So we can call that equilibrium rule. And the sum of all my forces equals 0 because we're in statics. We aren't moving anywhere. Our mass times acceleration is 0 because our acceleration is 0. So when I sum forces in the Y direction, I have negative 1,000 pounds plus 1 over square root of 5, TBC equals 0. So I get TBC over square root of 5 is 1,000 pounds. So TBC is going to equal 1,000 times square root of 5 is 2,236 pounds. It's a cable, so it's in tension. Okay, which I'm already indicating tension in BC. And now I can go back and sum forces in the X direction. Okay, I'm summing in the X direction. Forces to the right is positive. Everything equals 0. So negative TBA plus 2 over square root of 5 times tension BC. I've solved for 2,236 pounds. All of that equals 0. I'm going to pull this over to make it positive. So I have TBA equals 2 times 2,236 pounds over square root of 5. So I get TBA equals, so we have 2,236 times 2 divided by the square root of 5, and I get essentially 2,000 pounds. So when I report an answer for a cable, I'm going to have the magnitude. It should be in tension with a cable, and then I'm going to have the units. If I have a negative, that means we're pushing in on the cable. And I'm just going to pull this over. If this were a cable, it works great in tension, but the second I try to push it, nothing happens. So it was zero tension. Okay, it's not holding a compressive load. We couldn't have a negative 50 on here because it deforms. Okay, so positive only with cables. So now that we have both of these, TBA, now we can go to our second node. So we're going to have a free body diagram at C. And again, we're going to draw it exactly like what we have in our given. And if you're having a hard time doing that, then just like take a piece of paper and cut a hole in it and just put it around the node like that. And then you can see, okay, I have 1,000 pounds going down and I have 3 cables coming off at C. Okay. So I already know that this one coming down, which is BC, I already found 2236 pounds. And we are still at a 1, 2 square root of 5. I also have tension CE. This was a 1, 1 square root of 2. And I have tension CD, 3, 4, 5. Okay. This time when I sum forces X, so I can sum forces X, I can sum forces Y. Both of these have unknown X's and Y's, so we'll get to practice doing our system of equations. So a great algebra review. So let's just start with summing forces X equals 0. And I'm going to come around. So I get, remember here's my rule, equilibrium in statics. So I have negative 2236 pounds, okay, times 2 over square root of 5 plus, minus, okay, minus 3/5 TCD plus 1 over square root of 2 TCE. All of this equals 0. Let's just solve for TCE so we can take the negatives over, okay? So I have TCE over square root of 2 equals 2236 pounds times 2 over square root of 5 plus 0.6 TCD. And now I can multiply both sides by the reciprocal. Okay, so I'm going to get TCE equals 2236 pounds times 2 over square root of 5 times square root of 2 plus 0.6 times square root of 2 TCD. And where's TCE? Okay, so now that I have this, I'm going to go ahead and simplify this. 2236 times 2 divided by the square root of 5 times the square root of 2 times, and I get that TCE equals 28.28, sometimes I have a hard time reading numbers, 28.34 pounds plus 0.6 times the square root of 2 times 0.6 times the square root of 2, okay, 0.8485 TCD. Okay, so if you know how to do substitution, you can just take a break and go to work the problem, but if you still need a review on how to do this, that's why we are walking through this so very slowly. Okay, so that's equation 1. Now I'm going to sum forces in the y direction. They equal 0 because, again, our mass acceleration is 0. We're in statics. Hopefully nothing is moving. And we're going to start here. So I have a negative 1,000 pounds minus 1 over square root of 5, 2236, plus 4/5 TCD, plus 1 over square root of 2 TCE equals 0. That's the one that I'll be able to sub in here. So I have 0.8 TCD plus TCE over the square root of 2 equals 1,000 pounds plus 2236 over root 5 and we get that equals 2,000 pounds. Note, I'm trying to keep up with my units. Okay, so now we can go here 0.8 TCD plus, to put TCE, fill it in, 28.34 pounds divided by root 2 plus 0.8485 TCD divided by root 2 equals 2,000. So I'm going to take this over here, okay, and then combine these two like terms. So I get 0.8.8485 enter, 2 square rooted divided by, which is 0.6. I'm going to add 0.8 and 0.6, and I get 1.4 TCD equals. Then I have 2,000, and I'm going to subtract 28.34 divided by the square root of 2, and I get 0. When I plug this back in up here, then I'm going to get that TCE equals 28 pounds. Okay, this is the problem with me completely making up problems. I have the tension in CD equals 0. The tension in CE is 28.4. So this cable is holding nothing. This cable is holding all of the tension. And I can go back and check by resumming forces X and Y at C, and I should get a true statement that the sum of the forces X, okay, these values equal 0, and if I sum forces Y. So let's just check the X really quick. Okay, summing forces X, I have 2 over root 5 times 2236, and that is negative. And then I'm going to get 1 over root 2 times 28.4. That's positive, and when I add them together, I indeed get 0. So I'm pretty safe in betting that that is the final answer. Remember, always box your answer and always include the units.